So what I'm going to walk you through is my thought process of how to work out unfamiliar conversions so that you can use this then going forward for ones that you may face. So sort of a step-by-step guide of how to do it. What I like to do is leave a gap either side of the reactant and the product because I don't know what is going to go there yet, right? Whether that's electrons or H plus or water or so on. Just leave space either side so you can insert whatever's needed. Then the next thing you need to do is work out the oxidation state of the sulfurs and the oxygen to determine whether this conversion is a oxidation, reduction, or perhaps unchanged. The redox numbers remain unchanged, so it's neither an oxidation or reduction. It's just a conversion. So that's the first thing to do. And the reason why we need to do this is so we can find out where the electrons are going to go. Right, so with that said, this is assuming you know how to do redox numbers. If you don't, I have another video on that you can watch. So go and check it out. So oxygen is -2, and there's 4 lots of -2. And you can see the overall charge of the sulfate ion is -2, so therefore oxygen, sulfur must be +6. Then we go to the right hand side, do exactly the same, so it's -2, -2. And we can see for sulfur dioxide, the oxidation state has gone from +6 in sulfur to +4 on the right hand side, so therefore it has been reduced. So the electrons must go on the left hand side. Now, I turn my attention back to the original question, which says show the conversion of SO2- into SO2. And it says in acidic conditions. With the condition, you must always place that on the left-hand side because that's the condition the equation is operating in. And then finally, we need to introduce water onto the right-hand side. Now, why is this? The reason why is because we have oxygens and hydrogens on the left-hand side and only oxygen in SO2. So we need to introduce a source of hydrogen, and the best way to do that is using water. Okay, so generally you put water in, you can put it on left or the right because all of these reactions happen in aqueous conditions, and it's to balance oxygens and hydrogens. Okay, so you can put it left or right depending on where it's needed. So now that I've done that, the next thing I need to do is balance the equation. And what I like to do is I do the atoms first and then I do the charges at the end. Let's just get rid of these redox numbers for the moment because we don't need them. And go ahead and balance. So we can see we have 4 oxygens on the left and there's 3 on the right. So what I need to do is put a 2 there. Now that's changed the hydrogens. We have 4 on the right and therefore we need to put a 4 on the left. So as it stands now, we have 1 sulfur left and right, 4 hydrogens left and right, and 4 oxygens. Now you will see on the left hand side the total charge is 0. There's no charge on the sulfur dioxide and there's no charge on the water. So that means the left hand side also has to come to 0. So we have +4, because it's 4 times +1 is +4. We have -2 on the sulfur and an electron. So for this to come to 0, we have to put a 2 there because +4 -2 in the sulfate minus another 2 is equal to 0. So do an atom check first, then check the charges. And if the total charge is 0 on the left, then it must also be the same on the right. Or if it's -4 on the left, then it must be the same as on the right. I hope that's helpful. I am now going to do 2 examples in alkaline conditions, or basic conditions. And for that, you'll have to jump over to the other video I've made. So, see you in the next one.